In this video, you will learn how to find the probability of an event, how to use permutations or combinations to find the probability of an event, and how to find the odds in favor or against an event. Let's look at what probability is. Probability is the chance that an event will occur. A desired outcome is a success, and any other outcome is a failure. The way we write this is that the probability of success is P of S, where S represents success and F would represent failure. The probability of failure would be P of F. Again, S being success and F being failure. What you will notice is in the numerator of both of these, you're going to have the total number of ways that you either succeed if you're doing success, or that you fail if you were doing failure. In your denominator, you notice they're the same. Successes plus failures, so the total number of ways. What that would mean is if we were to add the successes probability and failure probability, we should get a value of 1. The probability of success and the probability of failure are also called complements, since the two together total a value of 1. If you had an event that could not possibly fail, for instance, if it was currently raining outside and you asked what's the probability it's raining outside, that would be a probability of 1. It is currently happening, it's going to rain. If you had an event that was not possible, such as you said, what's the probability that 2 plus 3 equals 7? Well, since 2 plus 3 will never equal 7, the probability of that event happening is 0. And so therefore, the probability of success always has to be between 0 and 1. And that's where we get our diagram from below. The probability that an event is less likely to occur is when that probability is somewhere between 0 and 1/2. It's more likely to occur if that probability is between 1/2 and 1. But again, as you notice, the value is always going to be between 0 and 1. Let's now look at the first example. Let's say you had 3 cards that were going to be drawn from a deck at random. What's the probability that all 3 cards are clubs? Remember, we need to find the probability of success so that those cards are clubs divided by the total number of ways to draw 3 cards. So if I want to know the probability that I'm going to draw 3 clubs, let's refer to our deck of cards chart to see how many clubs there are. I can see that there are going to be 13 cards in each suit. Before we can move on and decide some values, we need to first decide if order is important. We just want to know the probability of drawing 3 clubs. It didn't matter if you drew club being an ace, then a king, then a queen club. They just had to be clubs. So order is not important. Since order is not important, we need to do a combination. And so, the way that I can draw 3 clubs, we need to know how many clubs there are. Again, on your deck of cards sheet, it says that there are 13 cards in each suit. So what that means is from 13 clubs, I need to choose 3 to be successful. In the denominator, I want the total number of ways I can draw 3 cards from a standard deck. In a standard deck, there are 52 cards. Again, I'm drawing 3. If we remember how to calculate this in our calculator, we're going to want to do 13 math, scroll over to probability, and the third one is NCR for combinations, 3, enter. So 286 in the numerator. In the denominator, I have 52, 3, and that's 22,100. The last thing I need to do is see if this fraction simplifies at all. We almost always want to give our probability in terms of a simplified fraction. So to simplify this fraction, I could do 286 divided by my 22,100. And if I do math, the first one is frac. That will change my decimal to a simplified fraction. So this simplifies to 11 over 850. So the probability that you would draw 3 clubs from a standard deck of cards would be 11 out of 850 chance. Let's now look at the next example. It says that 2 dice are going to be thrown, and we want to know the different probabilities. Again, if 2 dice are being thrown, I would direct you to your deck of cards sheet. At the bottom, there was this list of 2 dice possibilities. In example 3, we want to know the probability that both dice are going to be 4s. So if I look on the deck of cards sheet, this is the only place where I see both dice being 4s. So that means out of the 36 possibilities, 6 times 6, only one of them is a success of both dice being 4s. So if I take the total number of combinations where both dice were 4s, 1, and divide it by the total number of combinations for throwing 2 dice, 36, and simplify if needed, I get 1 over 36. Let's now look at the one below. We want to know what the probability is that the 2 dice are going to add to 13. Again, I would look at my dice sheet. I want to know where I have values adding up to be 13. Well, 1 plus 1 is 2, 3, 4, etc. That's only 7. That's only 8, etc. The largest value I have would be the 6 and the 6. That's only 12. So that means there's going to be 0 times where they add to 13. So the total number of times the dice will add to 13 is 0. Divided by the total of 36 simplifies to 0. Let's now look at E. They add up to a number that's at least 2. Well, remember, at least 2 are the values 2, 3, 4, all the way through our total of 12. So again, looking at the dice sheet, at least 2, well, this is 2, 3, these are all greater than 2, these are all greater than 2. Really, our whole possibility, every single possibility when you throw 2 dice is going to be at least a value of 2 when you add them. So what this means is because every single time I throw 2 dice, I get a value that adds to at least 2. There are 36 possibilities, and anything divided by itself is a value of 1. This event could not fail. I'm always going to get a value of at least 2. Please now pause the video and complete B, D, and F. For B, I wanted both dice to be an odd number. Odd numbers are 1, 3, and 5. And so if I look at the deck of cards sheet, 1 and 1 are both odd, but 1 and 2, the 2 is even. 1 and 3 are both odd. 1 and 5 are both odd, etc. These highlighted 9 possibilities are the only time where both dice are going to be odd values. And so that meant I had 9 possibilities of success over 36 total, and that simplified to 1 out of 4. On D, you should have found 5 times where the values add up to 6. Out of 36 doesn't simplify, so we leave it 5 over 36. Similar in F, there are 11 times where at least one of the dice is a 6. Out of 36 is 11 over 36. Let's now take a look at example 4. In example 4, it says you have an equally likely chance of choosing an integer from 1 through 20. Find the probability of the given event. A lot of times with these, I like to start by actually looking at a list of the numbers 1 through 20 I have to include. So now that we have our list written out, A says I want the probability that a perfect square is chosen. So we have to look at how many perfect squares we have from the numbers 1 through 20. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 16. And so that means I have 4 values that are perfect squares, and I have a total number of, if you count this up, 20. And so 4 over 20 simplifies to 1/5. I have a 1 out of 5 chance of choosing a perfect square of the numbers 1 through 20. Now in part C, it's asking for a factor of 30. So we need to identify what our factors of 30 are. Remember, a factor means that that number divides evenly into 30 in this case. So 1 divides evenly in 2, 3, 5, 6, 10, and 15. Those are the only values 1 through 20 that would divide evenly into 30. Since there are 7 factors of 30 from 1 through 20, 7 over our total of 20 would be the probability that one of those factors is chosen. In example B, we want to know the probability that a single digit number is chosen. Single digits are 0, 1, 2, all the way through 9. Because 0 is not in our set of 1 through 20, we will only include 1 through 9. So in our set from 1 through 20, there are only 9 single digits, but again 20 numbers, and since 9 over 20 does not simplify, that's our answer. Let's now take a look at odds. The odds of the successful outcome of an event, meaning in favor, is going to be the ratio of the probability of its success to the probability of its failure, which would look like this. The odds of an unsuccessful outcome of an event, or the odds against an event, is the ratio of the probability of the failure to the probability of the success. Something I would like you to notice is that the odds are not going to be over a total. The numerator and the denominator need to add to the total. Because they are going to be adding to the total, and this is not a probability, this is an odd, the value we get for an odd does not have to be between 0 and 1. Let's now look at example 5. In example 5, a card is drawn from a standard deck of 52 cards. We want to first find the odds in favor of drawing a 10. So if we want the odds in favor, we want the probability of success divided by failure. And so success here would be drawing a 10 from a deck of 52 cards. If you look at your deck of cards sheet, there is going to be 1, 2, 3, 4 10s in each standard deck of cards. That means I have 4 cards. I need to draw 1 to be successful. But to fail, there are 48 cards, and I would draw 1. It happens that when you're doing a combination or a permutation, and you only need 1, that's the same thing as doing 4 over our 48, and that's going to simplify to 1/12. You have a 1 out of 12 odd of favor of drawing a 10. Let's now look at the odds against. This means that I want the probability I fail divided by the probability I'm successful. And so, for clubs, we have 13 clubs. So I need the number of cards that are not clubs. 52 minus 13 is going to be 39. Choose 1. Divided by, there are 13 cards where I would be successful and draw a club. So 13, choose 1. This simplifies to 39 over 13, which is a value of 3 over 1. Always leave odds as a fraction, even if 3 over 1 simplifies to just 3. Please now pause the video and complete example 6. Please now check your answers for example 6. Notice again, I never put anything over a total because both of these were odds. Please now pause the video and complete example 7. In example 7, we were going back again to find the probability, which remember was number of successes over the total. Please check your answers for example 7. Please now pause the video and complete example 8. In example 8, we were again doing probability, and here in A, order was important. Now there is only going to be one correct order that would introduce the cereals in order of their suggested retail price. But as far as total orders, that, because order was important, I had to do the permutation, 5 cereals, arranging all 5 of them, and that on my calculator gave me 120, and so for the probability, 1 over 120 would be our answer. Please now complete B if you did not have A correct. We only have one multigrain cereal, so that's the number of successes, but there were 5 different cereals that could have been introduced first. So the total of 5, if we do the probability, 1 over 5. Please now pause the video and complete example 9. In example 9, we went back to finding odds. So remember, this does not go over the total. In A, there's only 1 6 on a die and 5 other numbers that are not a 6, so 1 out of 5 odd in favor of rolling a 6. In B, odds against an odd number, well, there happens to be 3 numbers that are not odd, even, and 3 numbers that are odd, and so 3 over 3 simplifies to 1 over 1. Remember to always write it as a fraction. Please now pause the video and do example 10. For part A, we want the probability of drawing 1 red and 1 black. Remember, the word "and" means both events should happen, and so you want to multiply these two probabilities. So the probability of drawing a red would be taking the 6 red marbles divided by the 27 total marbles we had, times probability of black, 9 black, divided by the total of 27 that we have. We are going to assume that they're replacing the marbles because they have not told us otherwise, hence still having 27 marbles. So multiplying fractions straight across and then simplifying, you have the probability of drawing 1 red and 1 black of 2 over 27. Please now pause the video and complete B and C and D. For B, I had to add the 2 probabilities because it was one or the other. In C, it was the odds in favor, and because it's odds, notice I'm no longer over the total. Because we wanted favor, I wanted the probability of doing the red. There's 6 red. Denominator, probability not red, so 21, which simplified to 2 over 7. In D, odds against, in the denominator, you want the probability of the black, so 9 black marbles. And in the numerator, you want the ones that are not black, the other 18. 18 over 9 simplified to 2 over 1. Please now complete the homework assignment for day 5.